So to illustrate, what I want you to do is, we need to draw some pies, okay? I want you to draw, we'll compare, not these numbers, we'll come back to these in a second. I want you to compare two different numbers. So I'm going to do a little new subheading for me, okay? Let's call this pie example, because I like pies. Okay, now I want to simplify it for you. I'm going to give you two fractions of the pie, which hopefully you'll be able to tell me immediately which one is bigger. I'm picking them as an example because you know, right? So that we can illustrate the concept and then come to something you don't know. So when I write these down, don't just shout out which one's the best one, because I'm picking it because it's an obvious example. I'm going to show you the process of how to order these fractions, and then we'll have a look at this where it's more tricky. Okay. So here are the two fractions that I'm going to give you a choice of. 2/3 or 3/4. Now, hopefully you can see which one is bigger because you're familiar with thirds and you're familiar with quarters. But how can we be sure, right? Not just like, oh, I think it's that one, just experience tells me. How can we mathematically demonstrate it, okay? And this is where I want you to help me by drawing some pies, okay? So, I need a new column, but maybe right underneath this, I'd like you to draw for me 2 rows of 3 pies. Let's just look at it top down because that will make it easiest. Now each of these rows, okay, they correspond to one of these fractions, okay? So we're going to make this the 2/3 option, and we're going to make this the 3/4 option, okay? Now, have a look at this with me, and it's important you have them set up like this, okay? Let's think about the 2/3 one. 2/3. Now, how would we divide this up accurately into thirds, okay? I want you to remember back, we did some work on angles, didn't we? Angles? Do you remember those? Okay. So, just off to the side, you don't need to draw this part. Okay? If you have a full revolution, how many degrees is that? That's 360 degrees. Now, if I want to divide that into 3 equal parts, I take 360 degrees, I divide that up, and I get 120 for each section, okay? So I could get out the practice and make you draw this exactly, but I reckon you can draw it pretty close. I want you to draw the center of the circle, stick it in there, okay. And now let's try and divide this up as best we can into equal sections. So I'm guessing it'll be something like this.
Calm down.
Okay. So I've divided up my pie into thirds.
Yes.
Okay, thirds. Good. Now, by the way, it will help if you have other colors there, but if you don't, just do some dotting or shading to do the equivalent. Okay. Now I'm going to shade 2/3 of the pie. Okay, let's do that. I'm going to use this color. Let's shade 2/3 like so. There's 1/3. And there's 2/3. Cool, looks good. Okay. Now let's do the same for 3/4, but obviously because it's quarters, not thirds, I'm not going to divide up the circle like this. We come back to our 360 degrees. You divide that by 4 to get quarters. How big will each sector, how big will its angle be? If you divide by 4, you'll get 90 degrees. So they should all be right angles, shouldn't they? Okay, so let's draw that in. Okay, so there's my center of the circle, right, where those two lines meet, and there are all of my quarters. In a circle, they're also called quadrants, by the way. But let's move on. Shading your 3/4 as well. Okay, so there's my 3/4. Okay, and so now, in case it wasn't already obvious before, you can see which one is a better deal. Okay. But, number 1, we want to be able to show that mathematically, not just with a picture. And number 2, we want a way to do this that will work with these. Like, I don't know how to divide up a circle nicely into 17ths, whereas thirds and quarters are quite easy, right? Even 5ths and 7ths are a bit of a challenge. So, let's watch what happens. Now, what I want, remember we said, integers, they're really easy to compare, right? Some fractions are really easy to compare as well. For instance, if I took all of these numbers and divided them all by 4, So if I had 1/4, 2/4, 3/4,
There'll be a lot of quarters.
even though they're still fractions, they are very easy to compare, much easier than these or these. Why? Why are they easier to compare? Chelsea. Aha. Because the denominators are the same, I can just compare them in the same way that I have these because they're all equal. Right? Same denominators, a better word for them, a better phrase for that, is that the 4s are a common denominator. That's an important phrase to have. Okay? A common denominator. You should jot that one down. Common denominator. This is what we want. If we can get a common denominator between our fractions, whether there's 2 or 3 or 300, then we can order them. We can compare them and order them. Okay? Now, how do we do it? Okay? Well, for starters, what I want you to do first is I want you to redraw the same divisions that you had for the 2/3 and the 3/4. Draw them on the next circle, but we're going to add some new stuff onto it. Okay? After you've done that. So divide it up just like you did before. This is still going to be thirds. Okay. And this is still going to be quarters here. Okay. Now, I'm going to do this twice. What will let us get a common denominator? I'm going to do it once visually, and then I'm going to do it numerically. I'll write the numbers out. Okay. Here's what we're going to do. I should have shaded the 2/3, okay, and the 3/4. Like so. Now, in order to have a comparison between them, okay, see these thirds, right? Every third here, 1, 2, 3, I'm going to divide these thirds into quarters. I'm going to divide these thirds, each one, into quarters, so that there's thirds and quarters in the same diagram. So watch, right? For instance, have a look at this empty one over here. Okay, to divide it up into quarters, I will divide it up in half, and then I'll halve the halves. So now I have 4/4 of the third. Okay, so let me say that again. I took that third and I divide it into quarters. Okay, I'm going to do the same thing for the other two as well. Okay. Do you want to just leave it here for me? I can. Okay, there's one more. Here we go. There you go. Now you can see why I did it in a different color. So you can see, maybe if you don't have a different color, you can just make these lines thicker. Okay, I divided up every third into quarters. Now have a look. How many sections do I have now? How many sectors, rather? I have, well, because there were 3 before and they've all been divided into 4, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. Right? So, this one here is divided by 12. How many sections are shaded? You can count them, can't you? 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 over 12. Now remember what we looked at yesterday. What are these two? In relation to each other, they are equivalent fractions. Remember that?
Yeah.
Equivalent fractions. Okay, 8 over 12. Now I'm going to do the same thing down here, right? But these quarters, what do you think I'm going to do?
Third them.
I'm going to divide them into thirds, right?
Oh.
Divide these quarters into thirds. Okay, so watch. I'm going to get my other color out again. Divide that one into thirds. That's pretty close. Divide this one into thirds. This one into thirds. And the last one into thirds. Okay? Now, just like I did before, I now have 12ths. Can you see that? Can you see I have 12 sectors here, 12 here. How many are shaded? And it's 9. 9 over 12.
Are we learning pi?
Okay. We'll get to pi.
I thought this was pi. Can we actually have a pi break?
Okay. So, okay. What's our last pi for? Okay. Here it's a bit sort of unclear. I just want to have the 12ths in place so you can see what I end up with. Okay, so here's what I'm going to put in. And she goes that way. So 1, 2, 3, 4, 5. There we go. Okay, so what do I got here? I've got the same diagram. I've got the same diagram all the way along, okay? But here, it's just 12ths, right? Let me shade those in. Okay. There are the 8/12ths, okay? So what I want you to have on this final diagram just shows you what you actually got, and it disguises the process we went through to get there. This is sort of our final answer we can compare, okay? And we'll do the same thing down here to finish. There we go. There's the 12ths, okay? That's a beautiful pie, Noah. Wonderful. Okay. So there we go. Now remember I said I was going to do it two ways. I was going to do it visually. That's visually there. What have we done numerically? How can we write it out? Okay. Well, to get this, right, remember I divided the thirds into quarters. So what that is really is, maybe I'll write it over here because I actually have space. That's 2/3, right? I divided up this into quarters, right? But that gave me more sections that got shaded. 4 times as many. 4 times as many shaded parts, 4 times as many total parts, right? And that's what gave us 8/12, right? Here I divided the quarters into thirds, so I had 3/4 to start with. When I divided up into thirds, I had 3 times as many shaded parts and 3 times as many total parts, which is why I now have a common denominator, just like I had here. And now you can see it's super, super obvious. 8, 9, this is the better deal, assuming you like the kind of pie that I'm serving. Okay?